Hello and welcome to our May AMA. My name is Alicia and I'm here with Matt. We're really pleased to invite any of our community from North America or anywhere else for that matter to ask any questions that they might have in relation to contract testing, Pactflow, Pact, etc. Matt, should we maybe quickly kick off with an introduction of yourself and then we can jump into some questions? Sorry, just before we do that, as we have up there on the screen, if you do have questions, please pop them into the chat and we will answer those as we go through. We've also got some pre-arranged questions as well that we will kick off with. So Matt, over to you.
Cool. Thanks, Alicia. Good afternoon / good morning. My name is Matt Fellows. I'm one of the core maintainers here at Pact. Look after Pact.js, Pact Go, and other bits and bobs. Also the co-founder of Pactflow. Really excited to answer a few questions this morning. Hopefully you've got some extra ones lined up for us. And looking forward to get into it.
Awesome. Very cool. So maybe we'll start off, Matt, with a couple of those questions that we had listed out. So do you want to get one of those on the screen? Awesome. Nice, easy one, I reckon, Matt, to kick off with. So question 1, who authors Pact tests?
Yep, as usual, I will take us over to the FAQs because they're fairly extensive and the questions we get, we often get repeated, so we do try to put them in here, although I realize one of the ones we had this morning is not in here, so we should do that. Who would typically implement Pact is how it's been phrased in our FAQ docs. The short answer is it's usually a developer. It doesn't mean others can't do it, but 9 times out of 10 it will be someone who's got access to the code. And the reason for it is it's a white box testing tool. So white box meaning we need to be able to look at the code itself. We need access to the code to be able to do things like unit testing. We need to be able to mock out stuff. And you can't really do Pact testing from the outside. So we do have certain testers and SDETs and things like this who will do Pact testing, but you can't really do it from outside the code base, and that usually means that a developer or somebody who's working on the actual feature at the start is the one who's going to write the Pact tests. I mean, we're certainly looking at this in Pactflow, and we've got some new features and tools over there that expand it to more black box style. But if you're using purely Pact, then that would usually be an engineer working on the actual feature. I suppose the other thing to add here is like if you're working in a cross-functional team where you've got testers and developers and others all working together on features side by side, well then that sort of answers the question as well. Just really anyone who's actually working on the feature itself, who has access to the code base and whatnot. Now the other thing to think about is it's a unit testing tool. So particularly on the consumer side, it's much more of a unit test. So, unit tests don't usually get written after the fact. They're usually part of the development itself. And so when you're authoring code that's making an API call, that client API inside your, that client call from inside of your client or your application, that's the thing that's going to be unit tested. So that usually happens during dev, not after the fact.
Thanks, Matt. Nice. And just a note to everybody, we will post the links to some of these articles that Matt is sharing as he asks the questions through the chat on the description on the YouTube clip. So question number 2, can you do GraphQL testing with Pact?
Yeah. So sorry for those. We were going to talk about WIP and pending packs, but unfortunately Beth's been unwell, and we would really like her to answer that question because she does a better job of it. So we'll we'll move that to a different AMA. So this one is about GraphQL, which is a different type of I guess it's an alternative to standard RESTful services. It's really popular for backends for front ends of the BFF pattern. So what I'll do is I'll take you through to an article and also some examples that we can look at. I hope you guys can see that. So if this is what your API client might look like, so let's say this is a TypeScript version, I think, by the looks of things. And what we're using a GraphQL tool called Apollo. So using Apollo's client. And down the bottom here, you can see where the actual query gets called. So this is a pretty simple example. But you can see we're doing a query that's sending through the hello query, and it's passing through the hello field. It wants the hello field back. We're also passing through some variables. So this is very simplistic, but what a GraphQL query might look like. Now, the way Pact works in most of the frameworks, it can deal with, it does very well with JSON payloads and others like that. It can also do text and whatnot, but it can't do matching on non-JSON payloads or XML payloads. What I mean by that is it doesn't know how to parse the query itself into an AST and then semantically work out which parts are the things we can swap in and out, and we can be flexible in matching and that kind of stuff. So the first thing to note with GraphQL testing at the moment with Pact is that really you need to be very careful with what query you're sending, but you can still match that query, because on the consumer side, on the request side of a GraphQL interaction, it's just a string, but it's all an abstraction over REST. So we still can do GraphQL testing with Pact. So if I just go back from our consumer file itself to the actual spec, what we want to do here is we want to test that our consumer will send the right request. And then the response side is usually straightforward, because that's just like regular Pact. It's just going to be JSON. It's just going to be a content type of application JSON. And we're just going to get back some data that's either going to be a JSON object or a string, but it's usually a JSON object. So the main trick with GraphQL is basically capturing the query properly. Now in Pact.js, we added a little convenience function that says with query, and there's a GraphQL interaction that you can use. And then the rest of it kind of looks very similar to Pact. We've got a with query with an operation with variables. But really all that is a very basic abstraction over the way Pact already works. So if you actually see here with request, well, in the case of GraphQL, all requests go to the same endpoint and all requests are post. So that's easy. We can just do that. There's variables that can go into the query itself, which we substitute in and out. So again, we've got a query function that just passes that through. So if I actually go into the GraphQL interaction definition, let's go there. We can see actually what it does. Like you can see, it's a very simple class. All it does is map a few things. If we scroll down, the actual whole trick is down here. So what we do is when we're mapping the request side of the interaction, what we do is we're actually passing through a JSON object, which has the operation name, the query, the variables, and then passes in some headers. So we know it's always going to be application JSON we want back. Actually, that's the right type. And it's always going to be a post. And what we do is we actually take the query, the GraphQL query, and we just fix it to basically make it more flexible with all the white space, because often queries will put extra spaces or lines and things in there, and that will make the request side brittle. So actually this nasty little regex down here is kind of what's going on. It basically just replaces out all the spaces with regexes that say space can go in here. And then that's it. The query can now come through. So it's actually pretty straightforward. On the response side, it's really straightforward, because the response is just going to be JSON, just like Pact already supports quite well. So the trick is just going to be, just summing that back up, is doing this piece here. So not all languages, I think only JavaScript has this kind of convenience function, but as you can see, it's pretty easy to do it yourself. All you need to do is know the structure of the JSON that GraphQL is going to send on the consumer side, on the request side, and you just need to be able to deal with the query, which can be a bit dynamic, and you need to make sure that you can remove all the white space and bits that might change, even though the query itself hasn't changed. Now, quick side note as well, we'll be looking to do more of this over time. Once we've added the plugin ecosystem into the Pact framework, we hope to better solve the GraphQL a bit better and have first-class plugins for GraphQL. And also we're doing things over in Pactflow to support GraphQL in our new bidirectional feature. That's all I've got to say on that one. Of course, if there's any comments or questions on that, let me know.
Nice, Matt. Thank you so much. We've just had a question come through from a listener. If I can just table that one with you. So thank you so much. The question is, what tools would you recommend to expose the stubs of the dependencies of the providers?
So I might need some elaboration on that one. So what tools would you recommend to expose the stubs of the dependencies of providers? Yeah, so, well, I guess more generally speaking, with stubbing tools, you can obviously use Pact if you've got contracts for them. So obviously the further you go down the system with Pact to create contracts, you can use those contracts as stubs. So there's a Pact stub server, which you may or may not have seen. So if you haven't, I will just go back to that page and just mention that. Again, I think I use a search here more than anybody else. I think there's a stubs. Yep. So we have a tool you can use that will stub out your local endpoints. So you can, if you have a contract in place, you can take your contract, put them into the stub server. We have a few different types. We have this one here, which you can get from Docker. You basically pass in a directory or the file itself, or pass into a remote one, and it will just create a local stub server for you. We also have a bunch of CLI tools which you can use to do the same thing. Now, generally speaking, just in a more general stubbing situation, Pact isn't ideally suited to just general stubbing, in the sense that it's not a general service virtualization tool in that manner. The stubs themselves are generated from those contracts, which those contracts are going to be validated against the provider. So that means they're usually much more specific and narrow in their use. So using them as a general purpose stub can mean that they're not going to be able to be as flexible in that sense. So tools like Mountebank, you might still want to use for that purpose, but you do want to make sure you've got contracts between those downstream systems. I'm not sure if that answers your question, but if there's any follow up there, I'm happy to answer that. Sorry, the other thing I was going to say, I think we might have answered this in the call in yesterday's AMA or previous AMA. The other thing to look at is, where is it? Stub calls. Here we go. So I guess the general situation here is like, how do you not have to stand up the whole universe, right? So the part of this question is, well, when we're doing provider-side testing, we don't want to stand the whole universe up, because that's the thing we're trying to avoid by doing contract testing. So when you've got downstream systems of a provider, which may also have downstream systems of a provider and so on, we want to not have to do that, which is probably where that question is coming from. So yeah, the general technique here is to either stub out the systems. The other technique that I didn't talk about is just using that in a unit testing framework, right? So rather than having a physical mock server running on a separate port or a separate system that you've just mocked out, you can still do it in process. So if you're using tools like Jest or Mocha or Pact or JUnit, you might use Mockito. In the test itself, you can actually mock out those dependencies. Or if you're using Spring, for example, use dependency injection to replace out the real implementation with some in-memory one. So they're the kinds of things you would do. I tend, to be honest, in my tests to use the standard unit testing facilities, because they're much more simple, they're much faster. I don't need to run separate stub servers or anything like that, and I can manipulate the state in my code base, and I find that much more easy to deal with, and I find the tests run really quickly and it's less complicated to manage. But that's my personal preference. Cool.
Nice one. Thanks, Matt. And thank you so much to that listener who posted that question. Shall we kick on to some others? Awesome. Thanks, Matt. So question 3, why should consumer-driven contracts reside in the same repository as the service?
Yeah, there was quite a good conversation about this recently. There's no reason why they shouldn't. As in, you definitely can try to do it from outside the code base. It just gets really hard. And it kind of goes back to question 1, is on who authors the Pact tests. So if you imagine you're writing a set of unit tests, again, maybe we'll go back to the example code base from before. If we go to that, you'll be able to see why it's actually going to be a challenge to do it from outside of the code base. So I'll head to that page now. So this is my Pact JavaScript. This is the Pact.js repository, and these are some of the examples we've got inside there. And if I go to, I'll go to the end-to-end example, which is a bit more complex. We've got a consumer and a provider. If we go into our consumer itself, you'll see there's lots of calls in here down to the other system. So it's actually an API of itself, and that API makes downstream calls. So over here, for example, on line 63 to 68, make that a bit bigger, we can see we have a function that's called create mate for dates. So this is an animal dating service. That's the use case. And in here, we've got an API client that's making a call to create a new animal, basically. Right. And so this thing's a piece of code. We've got to test that. The target of our Pact test is going to be this API client. And so already you can probably see how it's going to be difficult to write a Pact test from outside of this. The only way we're going to be able to test it is to either unit test it, because we have access to the code, or to run it in a real life situation and somehow intercept the request to make sure we did what we thought it was going to do. So we can do that. It just makes it a lot more difficult to actually make sure your code does what it's supposed to do. So that's essentially some form of record and replay or proxy style thing. So that's the thing we need to test as part of our Pact test. If we go back and look at the test for that and go into our consumer spec, somewhere down here there's going to be a post. Here we go. So this is the test for creating a new mate. So between line 230 and 255. So you can see here, it's going to be making a post. It's going to post this endpoint. And you can see right down on line 253, we actually just invoke the method directly with the new suitor to be created, and it eventually is done. Now that probably can be updated now. It's a pretty old style of fulfilling that promise. But the point is, we can do that much more simply because we've got access to the code. If we were trying to do this from outside of the code base, the only option we've got would be to stand the whole service up, invoke the service from the outside. This is an API, so it'll be API calls to our service. And we would have to proxy the calls between our service and the downstream system to ensure that the system actually made the calls it was supposed to do. And then, of course, you would need to make sure it points at Pact, which is just going to be difficult. So that whole process is going to be very awkward and very difficult if you're doing it from the outside. So it very much is a white box testing tool, and therefore you really need access to the code. And that is the main reason why code should exist in a repository that you're testing, right? So we went through that journey to get back to, well, the code is all together. It doesn't make sense for the test to be elsewhere, because if the tests are elsewhere, when this code changes, you're not going to get feedback immediately that your code is not working, because the unit tests are somewhere else. So they'll have to run on the back of the code change. So what will happen is your CI pipelines won't make sense, because your CI pipelines will be green, and then some other pipeline that's running those tests, or a separate phase of that pipeline, will then go red because the implementation is now out of sync with the tests. So the old adage of things that change together, stay together. So this test is tightly coupled to that piece of code. Keep them as close together as possible, so that when there's a problem, you'll know where to look. If it's elsewhere, it's going to be this sort of lurking problem that comes back later. Now that's the consumer side. The provider side, you can do it from the outside. So again, let's go back to a similar example. We'll go back to the provider of this example. So this provider is an API. And as we know, the API in Pact, or the provider side and API, is provider side testing in Pact is a bit higher level, in the sense that you still need to stand the service up locally to test it. So again, this is just another server that's got an Express server in this case that has endpoints. That's what we're testing. If I go back to if I actually look at the test for this and go into the provider spec, you'll see up here on line 9 through to 11 that we actually start the service first. So before the tests run, the service has to be running locally. So because the service is running locally, we could test this from the outside. We could actually have a separate suite that would test this. Now, in this case here, we're importing classes, so that's going to be hard to do from the outside, but you could imagine a situation where you could stand a service up from the outside and then test it from the outside. But again, where it's going to get difficult is when you're doing things like request filters, where you want to manipulate state for authorization headers or something, or when you deal with state handlers. So in this case here, we want to be able to deal with a state where there is no animals. So we have an empty database. And so any request to get an animal is going to be a 404, or certain operations won't be available. And of course, when there is some animals, we want to make sure there's data. So on line 43, we're importing data for that state. Again, that's going to be very hard to do from the outside, or at least more complex to do. And so having it within your control is going to be much, much easier to do. And again, if you're doing that from the code base, that again is going to be much easier to do. Now, this kind of actually goes back to our other question around the stubbing question. So you can see here, we have this import data function. This actually deals with the fact that we have an in-memory repository we can replace. And so for this service, we can actually just replace out the implementation of the animal repository. And in our test, we can just manipulate that state much more quickly. So it's going to be doing it in memory. So rather than talking to a real database, we can just talk to an in-memory version of that. And then down here, we can actually just import data or clear data from that repository for the different states we need to manage on our provider-side test. And that's just going to make it really fast to run. So there's no talking to real databases. So it's going to be really cheap. And it's going to be really easy to manage because we can do it from the context of our test. So I hope that answers the question as to why you'd want your test to be in the same repository as the service, which kind of comes back to who authors that test in the first place.
Nice summary. Thank you, Matt. We've had another question come through on the chat. So this one is, what framework can I use for a unit test in Python for provider tests?
Yes. So I think you're asking what Pact. I think you sort of mentioned there the Pact Python as well as a question mark. Yeah. So Pact Python would be. I got that in my history. Oops. That would be the one that I would use. So there's actually a few. Let's go to the actual repository there. So Pact Python is the official Pact client, or the Pact client library for Python, and you can see it's part of the Pact Foundation. So yeah, this is the standard one I would use to do your Python testing. I'm not sure if you're asking for unit test frameworks within inside that. I know PyTest is, I think PyTest is the one that's actually used inside here, but I'm not a Python expert, so I probably won't be able to give you too much advice just here on that, but happy to follow up afterwards with you if you want to join the Slack channel or ask any questions there. But yeah, this one's the official one. There is Pactman. So you might have come across Pactman, which is a community contributed framework, I think created in the last couple of years, but it's not currently following so it does support some things that Python doesn't support from memory. The downside though is that what we've been doing across all of our open source frameworks is standardizing on a shared core, which is it's currently in Ruby, which is the users, but it's actually moving to Rust. So if you look at a lot of languages, we're currently actively moving the core engine up for a bunch of future features. For example, there'll be through V3 and V4. Also, we'll be building, or we proposed a plugin engine. And that question comes a bit, and we'll talk about the next AMA is what the plugins might look like and why we're building it. But the plugin engine would enable us to add things like GraphQL by having one single contributor create a plugin for GraphQL, and that plugin is available to all the languages immediately. So the strategy is moving everything onto a shared core to simplify the matching logic and rules, because there's a lot of complexity there. That's a source of bugs. So the more we can keep that consistent, the more consistent the framework will be, the simpler it will be, and easier to author as a maintainer. And then once we've done that, we can then make it easier to add new plugins and extend the functionality much more quickly. And so that's our key strategy. And Pactman is not currently working that way. It's all pure Python, which has its benefits, but the downside is it's not working towards those goals. Hopefully that answers the question.
Nice one. Thanks, Matt. Let's check if we've got any more questions that have come through. It was just those three that we had tabled, didn't it? Wasn't it?
Yeah.
Yeah, awesome. Let's have a look on Slack. As you mentioned just then as well, of course, if people have additional questions, you can definitely get those over in our Pact Slack community. There's heaps of people there who are able to answer your questions, as well as Matt and the rest of the group. A couple more that are coming through. So where do you want to start, Matt?
We'll start with Dimitri's one because he's came through first and I've clicked on it already. So
lovely.
Do you want to read it for us? Yeah.
Yeah, for sure. So thank you, Dimitri. Let me read this out. So how to verify WebSocket messages with Pact. One should create some proxies to get messages as Pact is abstracted from transport, but this will bring some unneeded overheads to simple gets. Sad face. How do we solve for that one?
Yeah. No, it's one of the reasons why we're pretty excited about the plugin architecture, because it will enable us to create a WebSockets transport and make that a bit more, I guess, a bit more friendly or a bit more idiomatic. So the way, as we talked about probably in the previous one, is how messages work in Pact. So messages are designed, as you said there, to be abstracted from the transport. What we really care about is the payload going over the wire. Now, if you're dealing with WebSockets in a unidirectional way, so it's fired and forget from one side, then you can use messages to do that. As you know, you can use message pack for that. If it's request response, that gets a bit more cumbersome because you need to actually do one request initiated from the consumer to the provider, and you need to do it the other way around as well as two separate sets of tests, which is a bit frustrating. So this kind of goes into the next question from Boris, but in version 4 of the Pact specification, the introduction of request response versions of async messages comes through. So in v4, you'll be able to have a single request with multiple responses, which is really nice because that'll work more for things like gRPC, where you've got streaming. You might publish one request, but you get back a streaming response from the provider. And if you have multiple requests from the consumer, you just make multiple Pact tests. And of course, that will work for WebSockets and anything else that does that kind of streaming methodology. So how do you verify WebSocket messages with Pact? You don't necessarily need to create the proxy, but you'll definitely need a piece of code that's able to separate those out. So again, I'm gonna I'm gonna go back to the JavaScript code base and maybe just try and paint the picture again. So if I go to the examples, there should be a message Pact example there. There we go. And we have a consumer, and you'll see we have this sort of handler. So we have a handler here this is basically, let's imagine we've got a queue and we're sending dog messages onto a queue. And in here, we're going to be able to handle that we can actually get a dog. And so this here we'll take a dog object, which is currently an any. Don't know why we did an any as opposed to just actually make it a type. And you can see here we're checking if those 3 fields are there. Otherwise, we throw an error. Maybe that's why we did it. And then obviously, your code would do something real in real life. It would say the dog, it would do something. In the consumer test, what we're expecting to get here is, it's a slightly simpler version of this test. Let's just look at lines 20 through to 37. We just say, given that probably that a dog exists, we expect to receive a dog, and we expect the dog to have this shape. It's going to have an ID, a type, and a name, and it's going to have some metadata. And then what we do here is we're using a facility from the Pact.js class, which is going to take the dog and convert it into a synchronous call to this dog handler. If that was an asynchronous method, it would be different, but this just means we don't need to do any kind of intermediation. This is just going to take essentially that object without the matches and invoke this handler. And if that doesn't throw an error or you reject a promise or something, it's going to say it's okay to consume that message. So you could do that with WebSocket. Again, it's going to be abstracting away the WebSocket itself. You can see here there's nothing to do with what queue type we're using. It has nothing, there's no information about what the queue is. So if it was a request response WebSocket, you wouldn't be able to do both. You wouldn't be able to do the both sides of the interaction here. You have to. This is the consumer side. So if you need to produce one, you need to do a producer side test on this side and a consumer side test on the other side, which is just a bit cumbersome. So I'm not sure if that answers your question, but I'm happy to talk more on Slack, or if you've got more questions here, happy to answer it too. We might maybe move on to the next question, Alicia,
awesome.
and if Dimitri has more, we can follow that up.
Yeah, definitely. Easy done. So thank you, Dimitri. And Boris, thank you for your question. So Boris's question is, do I have to know anything about V2 or V3 Pact spec, or do I have to use the features of the appropriate Pact libraries for each platform?
That's a good question. And now I think I did see this in the forums this morning. It may well have been you who asked that question. I'm not sure. So sort of, but not really. So again, I'll go to our docs. Our docs does have a bit on this. So it's the kind of thing we don't really want people to think about actively, because there's enough things to think about already. But if we go into the Pact docs, there's a feature support link here. And the feature support does kind of talk about what features they have and what versions of the specification are loosely covered. So, for example, you can use this to go, well, what has it currently got, right? Now, I think there's also, there's those two things. The roadmap is something I need to do, actually. So down here, you've kind of got some idea of those. I think each language should also mention what specification it supports. And I thought this page actually had that, but looking at it now, it does not have that. So I think that will be the simplest thing to actually do, is get this updated to show that. I'm a bit confused myself. Anyway, so you do need to make sure that both sides of your integration point support the same spec. So, for example, if you're on the consumer side publishing a V3 spec, but on the consumer side, on the provider side, it only supports V2, then the matching rules are going to drop off. They're not going to work. And in fact, the format of the Pact file may not be read at all. So that's usually how it works. So on the consumer side, it needs to be at least the same as the provider side. So the provider side needs to be at least as high as the consumer side. So if the consumer is publishing a 3, then the provider has to also support 3. If the consumer is publishing a 2, then as long as the provider supports 2 or above, then you're usually okay. So most of the documents, most of the framework should say what specification they support, but I'm going to make an action after this to make sure that's the case, because I thought this page mentioned that and it doesn't seem to explicitly do it. So I've either got the wrong link or it's not very obvious, and I'll make that obvious after this call. Now, looking at you said currently have a mix of JVM and JavaScript consumers and provider. So I think what I saw this morning was actually a Clojure or a Linigan provider. Now, I think under the hood, that's going to use Pact JVM, if I'm not mistaken. And Pact JVM definitely supports all of that. And Pact JS supports, the standard version of Pact JS supports V2. And there's a beta version of that which also supports V3. But I'm fairly confident if using Pact JVM, it's up there. It's basically got the most feature-rich implementation, so it should be able to support pretty much every other consumer, except maybe with the exception of some of the Rust stuff, which I don't think you're doing. So if you were that person on Slack this morning, we'll get that answered for you. Yeah, that's all I've got to say, I think, for now. And as I said, I'll make the promise of getting this table updated today.
Nice one, Matt. Thank you so much. Well, that's our 30-ish minutes of AMA time done now. So we do really appreciate everybody joining and asking those questions. We're always here to help you. As I've just posted now in the chat, you can join Slack and jump in there and ask any of those questions. So let's wrap this up. We look forward to inviting you along to our next AMAs at the end of June. Matt, thank you so much for your time.
You're welcome. Thanks for having us, Alicia. And yeah, we hope to see you next time, everyone. Thanks.